Hello again. This video will be much shorter than the binomial video because geometric distributions are very similar to binomials, except for in bins, the n becomes a t, and for geometric, we're looking at bits. So things that are the same, two possible outcomes. That's the b in bits, right? So let me write my bins and bits over here. So this would be bits. It's out of order. B-I-T-S. Sorry, it's not bisit. It's not bisit, it's bits. So I'm going to go in that order. So B in bits is still binary, meaning two outcomes, success, failure for geometric. The I is still independent trials, less than 10% from the population. The T, however, in bins, it was a fixed number of trials. With the T in bits, we're interested in the number of trials until we get our first success. So how many times do I have to try till I succeed? And then finally, the S in bits is the same thing as bins. It's the probability of success does not change. So again, geometric, same as binomial, except for instead of having a fixed number of trials, I want how many tries until my first success. The formula is pretty cool. I typically use Q to the n minus 1 times P. What this means, remember, Q is failure. So if I'm interested in my first success, that means I'm going to fail every time prior. So this Q to the n minus 1 means I fail every time until, boom, I multiply by the probability of P. That's my success. Here are my formulas for mean and standard deviation. Well, mean and variance. Remember, standard deviation is just the square root of that. Square root of Q over P squared. That's my standard deviation. And let's just do one. I'll do it with the formula and with the shortcut. Let's find the various possibilities associated with dice simulation to come with probability. Let me go back to the dice simulation. I don't know what they told me about that. Roll a die until the number 6 appears. That's what our simulation is here. All right, find the probability a 6 will come up on the first roll. So in terms of the formula, what that'll look like, if I use that formula, that means I fail every time before the first roll, which is none. So here I'm going to succeed right away. So Q to the 0 is just 1 times P to the first. So that's going to be 1/6. Find the probability a 6 will come up on the second roll. So X equals 2. That means the first roll I failed. So the first roll I failed, so that's 5/6. That's my Q. And then I succeed on the second one. So 5/6 times 1/6, whatever that gives you. I want to go down here to the third roll, just to show you how this formula works. So if I succeed on the third roll, that means I failed. I have 5/6 the first two rolls. So 5 over 6 squared. And then on the third roll, I succeed. That's a little square. Let's go down here. Let's jump down here. If it's the fourth roll, you kind of see this. That means I fail, fail, fail. 5/6 to the third times 1/6. If I succeed for the first time on the fifth roll, that's 5/6. I fail the first 4 times, or 5/6 to the fourth, and then times 1/6. I succeed. So you can use this formula. It's not difficult to use. It's really just the multiplication rule. Or in your calculator, you go to Menu, Distributions. I keep going to Norm CDF. Menu, Probability, Distributions. There is a geometric PDF and CDF. They work the same as binomial. So you could pick PDF for these. Would be PDF 1 over 6. Let's just do the fifth roll. So that probability would have been 0.080. So you do have Geom, PDF, and CDF in the calculator. Let me go with one more. Well, maybe not. That's it. Oh, here, let's do this one. Find the probability to take more than 5 rolls. That means x has to be greater than or equal to 5. So intuitively, if I go back to this table up here, I'd have to find, if I go to my graph here, I'd have to find it for 5. Oh, so more than 5. That's my bad. More than 5 is just a greater, no equal to. That means I'd have to find it for 6, for 7, for 8, for 9, for 10, really forever. I'd have to add all those up to figure out the probability it would take more than 5 rolls. Let's see what that looks like in the calculator. So obviously I'm going to pick CDF, right? That's an inequality. So I'm going to go to menu, probability, distributions. I'm going to go down to CDF. My P is still 1/6. And my lower bound was 6, right? Greater than 5 means 6 or more. And then my upper bound is infinity. So I'm going to put my George Sink, 9999999. So I put my George Sink, click OK. Here's the probability of getting a 6 after the 6th roll. So what's that again? 0.402. There's a quick version of geometric. Again, very similar to binomial, but instead of the number of successes in n trials, now I want what's the probability it's going to take so many trials till my first success. One last thing I mentioned in the Google Classroom post, don't worry about any of these homework problems. We'll do these all in class. That's for the binomial or the geometric. Just worry about getting through these guided notes and watching these videos for your virtual Friday.